No other planet in the planetary group arrives at the components of strong Jupiter. With a breadth of 89,000 miles, the gas monster surpasses that of our Earth by a factor of 11. In principle, our blue home planet would fit into the grandiose Goliath more than multiple times. At the same time, Jupiter has about twice the mass of all the other planets in our solar system combined. At a typical distance of 483 million miles from the Sun, Jupiter routinely becomes the location of basic processes. Extreme weather peculiarities occur repeatedly on the volatile surface of this celestial body, at times presenting themselves as strikingly extensive. By far, the most well-known storm on the largest member of our planetary system is the Great Red Spot. Experts have been observing this colossal structure for centuries, yet the oversized anticyclone continues to present unsolvable mysteries to scientists to this day. What have we learned about the Great Red Spot so far? What secrets still remain to be uncovered? You can find out in today's video. If you're excited about remarkable discoveries and breathtaking scenes in the universe, be sure to subscribe to Simply Space and click the bell for regular updates on these fascinating topics. By giving us a thumbs up, you're motivating us and showing that we can keep you engaged with our content. Thank you. The gas giant. As mentioned at the beginning, Jupiter is nothing short of the king of our planetary system. No other member comes close to the monumental features of this cosmic giant. While the discovery dates of other celestial bodies can often be measured to the day, the case of Jupiter is somewhat more complicated. It is certain that scholars of antiquity were able to calculate the 12-year orbit of the gas giant. Named after the principal king of Roman mythology, Jupiter was first examined with a telescope in 1610 by Galileo Galilei, who quickly identified its four largest satellites: Ganymede, Callisto, Io, and Europa. The deployment of automated space probes in the early 1970s finally elevated our understanding of Jupiter to a completely new level. As its designation as a gas planet reveals, the enormous giant has no solid surface. Instead, it is composed primarily of gases. In the planet's deeper regions, the gas envelope transitions into a supercritical state. Experts suspect a solid core of ice and rock that surpasses Earth's mass by a factor of 20. Observed from the outside, Jupiter greets us with a wide array of colors. These vibrant features consist of cloud bands and vortices, which give the gas giant its distinctive striped pattern. The upper gas layers are primarily composed of hydrogen and helium, complemented by small amounts of methane and ammonia. The brighter bands are called zones, while the darker ones are known as belts. Researchers suspect that the lighter zones owe their color to ammonia ice. However, the darker belts remain more mysterious, possibly containing sulfur, phosphorus, and hydrocarbons. Despite the constantly shifting states of the gas giant, the existence of long-lasting features such as the Great Red Spot is a testament to its dynamic atmosphere. The Great Red Spot. Reconstructing the precise history of this massive structure is challenging. It is certain that astronomers in the 17th century already observed a prominent spot on the gas giant, though it is unclear whether this was the Great Red Spot. The first confirmed description dates back to 1831, giving the structure a verified age of over 190 years. Located in Jupiter's southern equatorial region, the Great Red Spot's diameter exceeds Earth's by 1.5 times. This enigmatic storm reaches wind speeds of up to 423 miles per hour. With its immense size and unparalleled longevity, the structure is unique among storms in our solar system. Despite numerous studies conducted since the 1970s by spacecraft such as Voyager, Galileo, and Cassini, no universally accepted theory fully explains the Great Red Spot. What is known, however, is that the storm system undergoes significant changes over time. These include variations in its color, size, and shape. Sometimes it appears brick red, other times salmon-colored or orange. The reasons behind this color spectrum remain unknown, with explanations ranging from phosphorus and sulfur compounds to organic materials. Similarly, the storm's size has fluctuated. Historical records reveal that the spot was once 3 times its current size. Questions and theories. The Great Red Spot's extraordinary lifespan, exceeding 190 years, is undoubtedly due to its immense dimensions. However, despite extensive scientific observations, its energy source and remarkable stability remain unsolved mysteries. Fundamental questions still need to be addressed before this enormous enigma can be resolved. These include the storm's red coloration, its variable yet consistent orbital speed, and why only one feature of this magnitude exists on Jupiter. In 1881, C.W. Howe proposed the raft hypothesis, suggesting that the Great Red Spot floats like a raft in Jupiter's upper atmospheric layers and is composed mainly of solid water structures. According to this theory, the Coriolis effect forms a Taylor column when a solid object moves through a rotating fluid. This column carries a relatively stagnant segment of fluid along its axis, aligning with the planet's rotation. Thus, Jupiter's massive spot would be situated at a specific latitude. Despite these historical theories and modern technological advancements, the Great Red Spot remains one of the solar system's most captivating mysteries. Scientists continue to seek answers to its many puzzles, each discovery bringing us closer to understanding this monumental phenomenon. No other planet in the nearby planet group arrives at the components of strong Jupiter. With a breadth of 89,000 miles, the gas monster bests that of our Earth by a factor of 11. In principle, our blue home planet would fit in excess of multiple times into the grandiose Goliath. Simultaneously, Jupiter has about 2 times the mass of all other planets in our solar system combined. At a typical distance of 483 million miles from the Sun, Jupiter routinely becomes the location of basic processes. Extreme weather peculiarities happen over and over on the unpredictable surface of this heavenly body, sometimes presenting themselves as strikingly persistent. By far the most renowned typhoon on the largest planet in our solar system is the Great Red Spot. Experts have been observing this immense structure for centuries, yet the oversized anticyclone continues to present unsolvable enigmas to specialists to this day. What have we learned about the Great Red Spot so far? What mysteries still need to be unraveled? You can find out in today's video. Amped up about notable discoveries and incredible displays in the universe? Then make sure to subscribe to Just Space and click the bell for regular updates on these thrilling topics. By giving us a thumbs up, you're encouraging us and showing that we can keep you engaged with our content. The gas monster. As mentioned at the beginning, Jupiter is nothing less than the king of our solar system. No other planet comes close to the monumental features of this cosmic giant. While the date of discovery for other heavenly bodies can often be pinpointed, it is more complicated for Jupiter. Scholars in antiquity were already able to calculate the 12-year orbit of this gas giant. Named after the chief deity of Roman mythology, Jupiter was first examined with a telescope in 1610 by Galileo Galilei, who quickly identified its 4 largest moons, Ganymede, Callisto, Io, and Europa. The launch of several robotic space probes, starting in the 1970s, revolutionized our understanding of Jupiter. As its designation as a gas planet suggests, Jupiter has no solid surface. Instead, it is composed almost entirely of gases. In its deeper regions, the gas envelope transitions into a supercritical state. Experts suspect a solid core of ice and rock exceeding Earth's mass by a factor of 20. From the outside, Jupiter displays a wide array of colors, owing to its complex cloud bands and vortices, which give the planet its distinctive striped pattern. The primary components of its upper gas layers are hydrogen and helium, with trace amounts of methane and ammonia. The brighter cloud bands are called zones, while the darker ones are known as belts. Scientists speculate that the lighter zones contain ammonia ice, while the darker belts likely contain sulfur, phosphorus, and possibly hydrocarbons. Although zones and belts run continuously along different latitudes, the unpredictable nature of Jupiter's surface creates some enduring features, such as the Great Red Spot. The Great Red Spot. It is challenging to pinpoint exactly when observations of this massive structure began. Astronomers in the 17th century noted a prominent spot on Jupiter, though it's unclear whether this was the Great Red Spot. The first confirmed description dates back to 1831, giving the storm an observed history of more than 190 years. Located in the southern equatorial region of Jupiter, the Great Red Spot's diameter exceeds Earth's by 1.5 times. The mysterious storm reaches wind speeds of up to 423 miles per hour. Its impressive size and unmatched longevity make it unique among solar system storms. Despite decades of study, the Great Red Spot remains enigmatic. Space probes like Voyager, Galileo, and Cassini have observed the storm since the 1970s, yet no definitive theory explains its energy source or persistence. We do know that the storm system undergoes significant changes. Its color varies, sometimes appearing brick red, salmon, or orange. Scientists hypothesize that its coloration results from phosphorus, sulfur compounds, or organic materials. The size of the storm also fluctuates. Historical records show that it was about 3 times larger in the 19th century compared to today. Currently, the structure is contracting, but its future remains uncertain. Questions and theories. The longevity of the Great Red Spot, likely due to its enormous dimensions, remains a significant mystery. Several unresolved questions persist. Why does the storm have a red hue? Why are its wind speeds so variable yet stable in latitude? Why is there only one storm of this size on Jupiter? These questions trace back to the 19th century. In 1881, C.W. Howe proposed the raft hypothesis. According to this theory, the Great Red Spot floats like a raft in Jupiter's upper atmosphere, composed primarily of solid water structures. As a result of the Coriolis effect, a phenomenon called a Taylor column may form when a solid object moves through a rotating fluid. This explanation posits that the Great Red Spot is sustained by interactions between the planet's dynamic atmospheric layers. However, the mysteries surrounding this colossal storm are far from solved, leaving experts eager for more data and groundbreaking discoveries.